Now we will take introduction to numerical methods. If you don't understand anything, you can stop me and ask me when I tell you if you have any question. I will talk slowly, and I will explain everything in details and carefully to understand. Okay? Okay. Now, we have two major references. We have numerical methods for engineering for Chopra, and we have numerical methods for engineering and science for Amos Gilad. Also, I raise it on website. Did you see that? Where is website here? Okay. Look at this. Do you see that?
Yes, we can see.
Okay. This is a numerical method for engineering, and this is a numerical method for engineering and science. This is two books you can download from this website. And this is your syllabus. And this is the first lecture, and this is the second lecture. Okay, you can enter here, okay? Aren't you? Student.
Yes, we can.
Okay.
Yes, doctor.
Okay, you can download everything from this website, and I will record this lecture, and also as a video I will upload here. Okay?
Okay.
Good. Everything here. Let's continue. Okay, this is the two important references. You can download it and start reading. Now, what we have, what's the important subjects? I will explain something before continue. What we have? We have solving nonlinear equation, and we have curve fitting and interpolation. We have numerical integration. We have numerical differentiation. We have solving a system of linear equation, and we have ordinary differential equation, and we have partial differential equation also, and optimization. Okay, let's take one by one what we mean by this subject. Let's talk about the numerical methods, and then we come back here to explain this subject. Okay. What we have, why you should study numerical methods. Why you should study the numerical methods. First.
Doctor, sorry.
Okay.
Doctor.
Okay.
I'm just coming now.
Okay, remember me after we finish, okay? Who are you?
Sorry, Doctor.
Who are you? Your
I
name?
am Regan. Regan Rizar.
Really good. Rega is that okay? Done.
Okay, thank you, Doctor.
Done. Okay. We come back. What we say? We say why you should study numerical methods. It is very important subject. Then it's important for you in this stage to learn numerical methods. First, he said numerical methods are extremely powerful problem-solving tools. They are capable of handling large system of equations. What does that mean? What does that mean? Let's explain something here. Okay, let's take this equation. F of x equal x plus 3, for example. You see that?
Yes, we see, Doctor.
Okay. What's this equation? What's the name of this equation? What's the name of this equation? Anybody?
Linear equation, Doctor?
Yes, good. Why? Why it is linear equation?
It is M plus B.
Because the order of x is what? 1.
Is 1.
Good. This is first order equation. If I want to solve this, what I mean to solve this equation? Y is equal x plus 3. This is the same equation. If he say solve this equation, what's he mean? What's meaning solve this equation? It's mean make y equal 0 and make y equal 0 and find the value of x. Is that clear?
Yes, clear.
Now, to solve this equation, x, just to bring this here, x equal minus what? Minus 3. Is that true?
Yes.
What's that mean? Again, what's that mean? X equal minus 3. That's mean if I take, if I draw the coordinate x and y, and I want to plot this function or this same, if I want to plot this here, it will be like this. We say linear, صح? We We say what? Linear. This is the function. This is the function f of x equal x plus 3. What's this point? These points mean at y equals 0, x will be minus 3. That's mean I have point minus 3, 0. This point is intersection of the function with the x-axis. This point. This is minus 3, x minus 3, and y equal what? 0. Okay? Students, are you hear me?
Yes, doctor.
Is that clear? What
Yes.
I mean?
Yes, doctor.
Good. So if I have second order equation, let's we work here. If I have this equation, f of x equal x squared minus x minus 3, what's this equation? What's order of this equation?
Second order.
This is second order equation. Okay. Now, let's draw with ruler. Let's take coordinate here. Okay, we say this is x and this what? Y. This is second order equation. Okay, if we say solve this equation, that's mean find the value of x, values of x. This function intercept with the x-axis. Okay, that's mean I will make it equal 0. X squared minus x minus 3 equals 0. Now I have to solve this equation to find the value of x variable. Okay? Now, how I solve this? How I solve this? Who tell me? I have two ways or more to solve this. By identical solution, by experiment, or by using what? By using the law, minus b plus minus where b squared minus 4ac over what? 2a. You remember that, huh?
Yes, doctor.
This is the law to solve second order equation or quadratic equation. Now, this is the the best way or the easy way to solve this, it will be x minus 2 and x plus 1.
X plus 1.
Sorry, let's this equal 2 to be minus 2 and plus 1. Okay, equal 0. Now either x equal 2 or x equal what? Minus 1. Okay. Now that's mean I have two value of x at y equals 0. That's mean 2 points, 2, 0, and minus 1, 0, because I put y equals 0. This is y. This is y. I put it equals 0, and I solved it to find the value of x. What does that mean? I have 2, 0, it's here, and minus 1, 0, it's here, and this will be like this. It's parabolic. Like this. This is the function. This is f of x equal x squared minus x minus 2. Okay, and this is the interception. This is 2, 0, and this is minus 1, 0. Okay, any question here? سؤال طلاب? Any question?
That's good.
Yes, you have question? You have?
لا دكتور.
Good. It is clear. It is clear to you.
Yes, doctor.
Okay. Now we have we talk two example. We talk two example, first order and second order. What we will do if we have just a minute, please. Just one moment. I will come back to you. Just a minute. Okay, let's we come back. We say we talk two equation f of x equal x plus 3 and f of x equal x squared minus x minus 2, and we solve it easy. We solve it easily. Now the problem when we have like this equation, x cubic minus x squared plus 3x plus 7, for example. Now if he say solve this problem, it will be very difficult for us. It will be very difficult. Then we need to use numerical methods. Okay. Then as he say here, it is a power solving tool to be able to solve any question. Second, many problems cannot be approached using canned programs if you are conversant with the numerical methods and are adept at computer programming. You can design your own programs to solve problems without having to buy or commission expensive software. We will use many programs like mainly we will use the MATLAB, and we will learn it inshallah, and we will use Excel to solve the problems. Then you need to make your program by yourself. Then, numerical methods are an efficient vehicle for learning to use computers. Yes, it's true. To start or to learn use computers, you need to learn the numerical methods. 4. Numerical methods provide a vehicle for you to reinforce your understanding of mathematics. That's great. What he say? Many people hate mathematics. Many students hate mathematics. Numerical methods make you reinforce your ability or your understand of mathematics, and you will love it. Then, okay. But sometimes when we use numerical methods, we will have or we will get some errors. We will get some errors, and errors, we have many types of errors. The first one, it's round-off errors. What's the round-off errors? Round-off errors, I explained here what he say. For example, I will take example here. If this function, for example, f of x equal x squared minus x plus 2, for example, if I want to find y when x equal 1.23, okay, I will just f of substitute x 1.23 equal 1.23 square minus 1.23 plus 2, and I will find the result. It will be, let's recalculate it. Let's recalculate that here. what we have 1.23 square minus 1.23 equal plus 2 equal what we have 2.28. It's equal to 2.28 29. Okay. Now, if we change this number, or if I take approximate number, I will take 1.2. If I take f of 1.2, it will be 1.2 square minus 1.2 plus 2. We calculate it again. 1.2 square minus 1.2 plus 2 is equal 2.24. Now we have two numbers, 2.24 and 2.28. Just what? This is a difference number. Okay? Why? Because we ignored the number. Then this is named what? It's named round off error. For example, here we have f of x equal x squared minus x, and let a or x equal 2.1236. If we take this number, it's equal 2.124, we will get 2.387, and if we take 5 decimal after the point, we will get 2.38. We have a round off error. If we subtract the first one from the second one, we have this is error. This is named round off error when we use the approximating. Of number. Okay, are you with me, student? Are you with me?
Yes, Doctor.
Okay, good. Now we have another type of error. It's named truncation error. What is this truncation error? This, for example, if I want to find sine x, it's equal x minus x cubed over 3 factorial plus x power 5 over 5, and so on. I mean x power to 9 or 9 factorial and forever. Analytically, if I calculate sine x directly, for example, pi over 2, I will get 1. Sine pi over 2 equal 1. If I use this item and I will ignore this, all of this I will ignore, or this maybe, I will take this 3 terms, just this 3 terms, I will get something or numbers near to the 1 but not 1. This is named truncation error. This is named truncation error. If I didn't take all terms, if I just take 2 or 3 terms from the equation. Now, total error, the total numerical error is the summation of the truncation and round off error. In general, the only way to minimize round off error is to increase the number of significant figures of the computer. We need to take 5 or more than decimal. For this, the true error, true solution is the solution used by analytical methods. Minus the numerical methods or numerical solution. This is the true error. True relative error. Relative, it's relative respect to something. Relative, it's mean respect to something. True solution minus numerical solution over true solution, and we take the absolute value. Absolute value to find. This is important. This is important law, and we will use it. Okay. This is the error, and we will use it when we solve an equation. Now, to solve an equation, we have methodology. What does that mean? That means I have to do steps. To solve the equation. First, I have to defining my problems. I have to understand what he wants, what's the problem. Then I need data. I need theory to make mathematical model to build my problems and use solving tools like computers, statistics, and maybe numerical methods and or graphics, or anything else. Then I will get the results and represent this as a figure or as a graph or as a table. Then I take it for my implementation in any fields I want it. Then I have to make these steps to solve any equation. Good. What we will use to solve problems by numerical methods, we will use two-way. We will solve equations by two-way. By two ways. First, by hands, and two, by computers. Computers, I mean by program or programs. What programs? We will use MATLAB and sometimes Excel. Okay?
Okay, Doctor.
Good. Why we using computers and the program? Why we just using hands, just our hands and solve? This is the reason. For large scale problems, we have many equations and we have many variables. It will be very difficult to use our hands. Then also large and long calculations. Sometimes some problems need long time, and it will be very difficult to get the result or the confidential result. I mean good result. I mean true result. Sometimes we cannot solve problems analytically. Then we use numerical solution by programming. Alhamdulillah. Sorry. Okay. The other reason, speed. Computer solve any problem fast and in seconds. For example, let's we take this problem. For example, this is MATLAB. If you want to solve this equation, you need maybe if you're good, you need at least, for example, 1 hour to solve this by your hand, at least 1 hour. But look, I use computer and programming. You solve this problem by seconds. Okay, or for example, this. Just seconds. Okay? Accuracy. Absolutely. When you use a computer, you will get what? The accuracy. You have the best result, and you be sure you are not in wrong way. Okay? Now, to use a computer program, you have many things you need to learn. Code, commands, many things you need to learn it, and important thing you need to save the commands to make your program. We have many commands for input and output of data, commands for defining variables, commands that execute mathematics operations, and commands that control the order in which commands are executed, commands that enable the computer to repeat sections of the programs, commands that create figures and graphical displays of the result, as we did. This is the graph to display your results. You don't need, for example, to see this table. This is the result of our solution, but it is not clear as the figure. As you know, at x-axis equals 0, we have 2, and this is increasing, and here it's down suddenly, and then increasing here, sorry, decreasing and increasing here, and suddenly it's give you a good indication about what's happened, like this. Also, this is give you indication what's happened in your problem. Okay, now this is the this was introduction to numerical methods and importance of numerical methods and why we use numerical methods. And we say if we cannot solve problems analytically, we have to use numerical methods. Any question till now, students?
دكتور
Yes.
احنا راح نستخدم هذا البرنامج هذه السنة، هذا الكورس اللي
أي
بتنزلونه.
الماتلاب، نعم راح نستخدمه إن شاء الله. We will use it. I will start it with you maybe in next couple week إن شاء الله. I need every one of you to start learning. يعني ابدأوا تعلموا عليه. شوفوا you can see many YouTubers talk about MATLAB. Just write introduction to MATLAB and solving problems. Any subject we will take, you can write it in YouTube and you learn. You need to install it in your computers, and I think you have a lab in your university, in your college. Is that true? You have lab? I mean,
Yes, we have.
Computer labs. And I asked Dr. Arkan, he said, yes, you have, and everybody could use these computers and learn about the MATLAB. Did you take it before? تعلمتوه سابقا؟ أحد يعني مشتغلين عليه سابقا؟
لا دكتور، هذا أول مرة نحن نقرأ.
هذه أول مرة. This is first time. Okay. Okay, I will start with you step by step, inshallah. And this is MATLAB, you know, it's very important for every engineer. very important, and it is very exciting يعني it's ممتع يعني if you learn it, you will love it. Okay, then maybe inshallah next week we will start, maybe when I come to your college inshallah. Now let's come back here. First subject we will take it. It's solving non-linear equation. Non-linear equation. Non-linear. This is non-linear equation. This is this is non-linear equation. We will use numerical methods to to solve this equation and find the value of x. Okay. Let's go nonlinear equation. What's about curve fitting? Let's explain something about every subject here. Nonlinear, we talked about nonlinear. Curve fitting, what's the meaning of curve fitting? If we have, for example, if we have data like this, x, 1, 3, 5, 7, 10, 12, something like this, and y equal 3, 7, 10, 11, 15, 20, for example. This is data. How could I represent this as an equation? As an equation. For example, when I have 1, x equal 1, y equal 3, and when I have x equal 3, y equals 7, and 5 will give me 10, 7 give me 11. What's if I have x equal 4? If I have x equal 4, what will be y? This is named curve fitting. We will make some steps or some operation to find the value of y when x equal 4 and when x equal 9, for example. I will find the value of y. This is or the inverse. For example, if I have y equal 14, what's x will be? This is named curve fitting or interpolation or extrapolation. This is the second subject. Third one, numerical integration. Numerical integration. Now, you know absolutely, you know, I have dy over dx equal, for example, x squared plus 3. Everybody know how to integrate this. It will be easy. Y equal x power to 3 over 3 plus 3x plus c. Okay, is that true? This is integration. I think you taught it last year in mathematics.
Yes, yes, doctor.
Good. But sometimes, sometimes you could not make integration. It's not easy like that. For example, dy over dx equal x sine x squared sine x plus or over ln x plus sine x. It's difficult to solve it analytically like this. Then if it is difficult to solve, if it is difficult to solve equation by analytical method, you need to use what? Student.
Using programming on computer.
You need to use what? What?
Numerical method.
Numerical methods. When we use numerical methods?
If it is difficult to solve.
If it was difficult to use analytical method. This is analytical. I use it. I integrate this by analytical method. But this is difficult. Then I will use numerical methods. Okay.
Doctor,
Yes.
how can we know it is difficult? Sometimes we can solve it, sometimes maybe we don't know the idea of analytical. It will be analytical, but we don't know.
Yes, you can use numerical. If you don't know how to solve this analytically, you can use numerical. Okay?
Yes.
That's what I mean.
Doctor,
Yes.
if we know that this one is solved by analytic method, but we don't know how it will be solved, we can use the numerical method?
Yes.
Okay.
Yes. This is numerical method. It's so easy. So easy to solve an equation. Just you need to learn the steps, how to make it. Okay? So just apply the steps. It will be so easy.
Okay.
And you will get the solution. Or by using program. Okay? Good. This is about integration. About differentiation, same thing. For example, if you have y equal x cubed minus 3x squared plus 3x, for example, to differentiate this, y dash equal what? Well, what? Anybody help me?
3x by 2.
3x squared minus
6x
x plus
3.
Plus 3. Okay. Now, this is also easy, and we solve it analytically. If we have some equation difficult, for example, sine square x by, let's say here x square, and here, for example, e is x square plus something like x cubed by xe by this is to differentiate this. It will be so difficult to differentiate it analytically. By analytically, I mean by law. By law, you talk it already, an integration and differentiation. Then we can use numerical methods. Now what I want, what I'm doing now, to explain to you why we use numerical methods. Why we use numerical methods to solve some equation when we could not use analytically methods. We will use numerical methods. The other subject, solving system of linear equations. System of linear equation. What's that mean? Linear equation like this: y plus 3x equal 5, and 2y minus, for example, 6x equal 10. This is what? What's this? Student, are you with me? Are you hear me?
Yes, doctor.
Okay. What's this? This is first order or non-linear or linear equation, sorry. And this is other equation. This is equation number 1, and this is number 2. This is named system of equation, system of linear equation. If I want to solve this, for example, I have to multiply this by minus 2. It will be minus 2y minus 6x equal minus 10. And to solve this, I have add this equation. This will be 0. This will be minus 12x equal what? 0. That's mean x equal 0. And substitute this here. It will be y equal 5. Now I solve it. It's easy to solve this by hand or analytically. But if we have system like this, for example, x plus y minus 3z equal 5, and 2x minus 2y plus z equal 10, and 3x minus 7y plus 8z equal 20, for example. Now it's more difficult, because we have three variables, z, y, x, and we need more time to solve it. Then we have many methods or many ways to solve this we can use grammar methods. If you talk matrices last year, I don't know, or in first class, first stage, we take you talk maybe grammar rule by using matrix. Did you talk it? Did you take it?
Yes, we took it. Take it.
When?
Matrix last year.
Last year.
Yes.
In mathematics.
Yes.
Good. You can use grammar rule to solve this, or you can use matrix, or you can use numerical methods like Gauss elimination or Gauss serial method or any other. Also take time. Then if we use computers, this will take just a second. Then this is about system of linear. What's about ordinary differential equation? Ordinary differential equation. I think, did you take the mass transfer?
هذا السنة هذا الكورس
and this is Mr. You will take it. What's about heat?
Same thing. Yes, something. Same thing.
Okay. About ordinary differential equation, it's like this. It's like dy over dx equal x squared plus 2, for example. This is named differential equation. It's easy to solve this by your hands. Just multiply by dx. It will be dy equal x squared dx plus 2x, dx. And then by integration directly, it will be y equal x cubed over 3 plus 2. This is dx. 2x plus c. This is named ordinary differential equation, and we will talk. We will talk about the specification of differential equation in next lectures, inshallah. But if you have like this, dy over dx equal x plus y. This is also differential equation, but you cannot solve it by this way. Then it will be so easy to use numerical methods. And if you have partial differential equation like this, dy, for example, over dx equal dy over dt because we have two independent variable or two dependent variables. Sorry, this is independent. This is independent. This is dependent. This is dependent. This is independent. We write this as a partial y over partial x equal partial y over partial t. This is named partial differential equation. And this is named ordinary differential equation. Why this is ordinary? Because we have one dependent independent variable, just dx. But here what we have, dx and what? dt. It's named partial differential equation. Sometimes, more times, we use numerical methods to solve this type of question. Okay, I explain all of this: nonlinear, curve fitting, numerical, integration and differentiation, and system of linear equation, and ordinary and partial differential equation. It is clear?
Yes, Doctor.
Inshallah. Okay. This is the first lecture. I don't need to make it long. And then I just will explain the first subject. We will take it, inshallah, next week. And we will talk about 10 minutes, inshallah, not more. The first subject, it will be what? It will be solving nonlinear equation. Nonlinear equation, it will be like this: x cubic plus x squared plus x plus d. This is named nonlinear equation. Objective is to find solution of f of x equals 0. We talked about that. If we want to solve equation, we make f of x or y equal what? Equal 0. Where f is polynomial or transcendental, we will talk about this now, function given explicitly. Exact solutions are not possible for most equations. We talk about that. If we could not solve equation analytically, we will use numerical methods. Now, for example, if we want to solve this, it's easy. X squared minus 1 equals 0. How I solve this equation?
X equal to minus and plus 1.
Yes, I have two ways. I can use it like this. First way, it will be x squared equal 1. صح?
Yes.
Then x equal minus plus square root over what? 1. Then x equal minus plus 1. That's mean x1 equal 1 and x2 equal what? Minus 1. Is that true? When I have x squared, how many solutions should I have? Must I have? How many?
2 solution.
Yes, why?
Because we have 2x.
X squared, not 2x. Because I have second order equation, I must have two solutions, x1 and what? x2. If I have x cube, I must have what? 3 solutions. Or I can solve this by different square. This will be x minus 1 and x plus 1 equals 0. Analyze this. This is named two different square. So will be now either x equal 1 or x equal minus 1, x1 and x2. Always I have two solutions. Then, sorry, not this. Let's take this. Let's take this. X cubic minus 3x squared. X minus 3x squared equals 0. How I should solve this?
Factory x. Factor x. It will be x12.
I will take x as
square. X square.
Yes, x squared minus 3x. Okay.
Okay.
Or
we can factor x square.
Yes, that's true. X squared, x minus what?
Minus
3 equals 0. Now, either x squared equals 0, that means x equals 0, or x minus 3 equals 0, that means x equals 3. It's easy. It's easy. Now, let's take another one. Let's take this. Let's take this. Sine 3x equals 0. Sine sine 3x equals 0. Now, how to solve that? How to solve that? I have to ask myself when sine angle, this is angle, equals 0, equals 0 when this angle equal what? Equals 0 or
pi.
Excellent. Or pi. That's mean 3x equals 0 or 3x equal what? Pi. Then
Equal to pi.
x equals 0. Sorry. No, pi. No, pi. Pi. Like this. Look at me. This is sine. And this is cosine x. And this is a unit cycle.
Yes.
Here we have sine equals 0 and here 0. This angle is 0 and this angle is equal what? Equal pi. Pi, I mean 180 degree. Okay? Then, or either x equal 0 or x equal pi over 3. Okay? In general, an equation, one variable can be written a solution of current. Absolutely. When we solve this equation and find the value of x, like here, like here, like this, and like this. This is named roots of equation. Roots of equation. These roots make the value of y equal what? Equal 0. Always y here equals 0. Where is the others? Where is the others for? Yes, here. For this equation, for example, at x equal 1 and x equal minus 1, this function will be what? The value of y here, y equals 0, and here y equals 0 at x equal 1 and at x equal minus 1. Then this is named roots of equation. Roots of equation. Okay. Some functions have many roots, like this. This function have, as you see, 1, 2, 3, 4 intersection with x-axis. This is 1, 2, 3, 4. We have 4 roots. Some we have 2. Some equation have what? Have 1 roots like this. This is touch x-axis. We have no intercept. This is intercept here, intercept. But this not intercept. What? Touch. Just what? Just touch x-axis. For this we have 1 roots. And if we have like this function, we have no solution. No solution. Like this x squared plus x plus 1 equals 0. I cannot solve this. We have no solution for this equation. That means this equation doesn't intercept with x axis. Doesn't like this. It will be like this. This is x axis. Doesn't touch or intercept with x axis, or maybe like this. This is have no solution. This is have no solution. To solving nonlinear equation, we have many ways. We have graphical. Graphical is just plot the equation and find the intercept point. And we have bracketing methods. We will take bisection method, and we have open methods. We will take Newton-Raphson methods. We will start by bisection method. Next week, inshallah. Face-to-face, inshallah. Bracketing methods, we have to have an interval. An include solution is identified. Always converge to this solution. I will explain it. And open methods, we have 1 point. It's enough to solve this. And we will use MATLAB to build in functions for obtaining numerical solutions. After we will take the bisection method and we learn the steps of solutions, we will take the introduction to MATLAB and learning how to solve solution by find roots by using MATLAB, inshallah.